Okay, hi guys. Right now we are looking at our last set of real notes from this packet. It's called GraphingUsingSlopeInterceptForm. This is page 28 in our Graphing Linear Equations packet. So we are going to put everything together that we've been talking about with slope and make sure we know how to use slope to actually graph a line. So slope-intercept form, in terms of vocabulary, we know slope-intercept form is y equals mx plus b. We know it's going to be a linear equation. We've got our x and we've got our y. And we know that the m stands for the slope. So the m, the coefficient of the x, stands for the slope, but this is called slope-intercept form. And the only thing we haven't talked about so far is this intercept. Now we did talk about what x and y intercepts are. So just for a second in our notes, we know that the x-intercept of an equation is where the line crosses the x-axis. So an x-intercept was when y equaled 0 because you didn't go up or down. And we also talked about how the y-intercept, where the line hits the y-axis, is when x equals 0. So because you don't go side to side, it's where it hits the y-axis. So if we look back at this equation and we say, okay, well, let's look at the y-intercept for a minute. If x equals 0, if I plugged in something for x, this whole term would go away. And we'd just get that y equals whatever this constant is out here. So when x equals 0, y equals this letter b. Well, that is the y-intercept because it's what you get when x equals 0. So this b right here stands for the y-intercept. There's no way to see the x-intercept directly from the equation, but this is called slope-intercept form because you can see the slope and you can at least see the y-intercept. And if we know those two things, we can actually graph this line without having to make a table, without having to find the x-intercept. We can graph it just from this. So we're going to skip the parallel vocabulary because we're not going to be doing that this year. You'll get that when you get into algebra, into 8th grade and into algebra. So let's just look at, again, the equation. A linear equation of the form y equals mx plus b is written in, and that is called slope-intercept form. Slope-intercept form. Where what is the slope? That one's going to be m. And which one is the y-intercept? That one's going to be the b of the equation's graph. So again, one more time, m stands for slope, b stands for, we'll just abbreviate it, y-intercept right here. So in this particular equation, y equals 2x plus 1, the slope is 2, and the y-intercept is 1. So let's see how we can use just those two pieces of information to actually get this equation on the graph and see what it looks like. What we've done in the past is we've made a table of values. What if x is -1, 0, 1, 2. We could plug it in and we could find y. But let's look at how we don't even have to do that if we know these two pieces of information and what they mean. So we're going to start actually by looking at the y-intercept, the one we haven't talked about very much. It's the b. I remember this by thinking begin with the b. We're going to begin with the b. The y-intercept is 1. Can we graph that? We know the line hits the y-axis at 1. So the y-axis is the up and down. We know it's going to cross the y-axis when y equals 1. So I'm going to put a dot right there. We know that that is a solution of the line because that's what the y-intercept is. If we plugged in 0 for x right here, 2 times 0 would be 0, plus 1 would be 1. That is the y-intercept, 0, 1. And then we know the slope. So we know that this line is going in which direction? If the slope is positive, we know it's going up this way. We know it's pretty steep because the slope is 2, but we can actually count the slope. We know that the slope, I'll put this down here, the slope is the rise over the run, or change in x over change in y, all the ways we've talked about slope. So this particular slope is 2. How do we make that a fraction so we can see a rise over run? We'd make it 2 over 1. So that means that from any point on this line, I can rise to and run to the right one, and I'm going to hit that line again. So the big thing is we're going to start with the point we already know. We know it hits right here on the y-axis at 1. So from that point, I'm going to rise to and run 1. Rise to, run 1, and I hit the line again. From that point, I could do the same thing. Rise to, run 1, and I hit the line again. Now, I ran out of room here. If I wanted to continue this, I'm going up to, right 1, and if I wanted to go this direction, I'd just do the reverse. Down 2 and left 1. Down 2 and left 1. It continues my pattern. So we get, let me get a different color here. We get a line that looks like this. And that was just by starting at the y-intercept, begin with the b right here, and then count your slope, your rise over your run, because you can see that in your equation. So up to, over 1, and we've got our line. We could have gotten that by plugging these points in and making a table and getting those ordered pairs, but if we know what we're working with, it's quicker to do it this way and not even make the table. So there is our line. Is it going uphill like we thought? Yeah, if it wasn't, we might need to look at that again and do something differently, because that's definitely a positive number, so it should go uphill. Okay, we are going to look at the next page and just do a little bit of practice just identifying the slope and y-intercept of the line. This is going to be super quick. Let's just look at A. This is page 29. Here is the equation, y equals x plus 3. And we want to know what is the slope and what is the y-intercept of that line. Okay, is this in y equals mx plus b? Yeah. Is there an m, though? What's in front of the x? It's just a 1. So what's the slope for this one? The slope would be the 1, the m. And which one is the y-intercept? The b. So if the equation is in slope-intercept form, if it's in y equals mx plus b, that's a really quick question to answer. You just identify the constant, or the coefficient of the x, the slope, and the constant at the end is the y-intercept. So if we go down, let's skip b for a minute. If you just go down to number 1 right here. And what is the slope and the y-intercept? I'm going to say m equals and b equals. Now in this case, is it in y equals mx plus b? It's really close. It's in mx minus right here. So can we change the subtraction into plus? Yeah, we're going to make it plus a negative. So in this case, the m, the slope, is 4. If we wanted to, could we turn that into a rise over run right now? Could we also say 4 over 1? Sure. Either way, 4 over 1. And what's the b? We just have to be careful that we don't say 1 here, because it's not really a 1. It's really a negative 1 on there. Y equals mx plus b, so b is negative 1. So in this case, if I were to graph it, I would go to negative 1 on my y-axis. That's the y-intercept. And then I would count my rise over my run. I would count up 4, right 1, and put another dot there. Okay, we're going to skip around a little bit just to practice graphing some more. Can we go all the way to page, this is really skipping, page 34. It looks like this. It's called Sizing Up Sand. All right. There's like a trivia question on here. The world's biggest desert, measuring 3.5 million square miles, is found in Africa. What's the name of this desert? So we're going to match each equation to its graph, and we're going to compare the slope and the y-intercept values so that we can look at the equation and find the graph that works, and then we'll be able to answer the question from this. So if we take a look, let's just look at the first graph that they give us and take a look at this line. Okay, first of all, what do we notice about it? It's going which direction? From left to right? It's going downhill. So if it's going downhill, we're looking for a slope that is negative. So as we look at all of these, we're looking for something where the number in front of the x is negative. So that narrows it down for us to either h or s or a, because s and a, those are really negative 1s in front. Maybe I'll just put negative 1 so I can see that. All right, and then what's the other thing that I know about it besides the slope? I can see this point right here. It hits the y-axis at 1, 2, 3, 4, 5, 6. Hits the y-axis at 6. So my y-intercept is 6. Could I count the actual slope right here to get from this point to this point? What's my rise over my run? Down 1, right 1. So my slope is down 1, negative 1, right 1, negative 1 over 1, which is negative 1. So which equation matches up with a slope of negative 1 and a y-intercept of 6? Definitely not H. This one here, all right, which one has the y-intercept of a positive 6? Looks like that's going to be S. Slope of negative 1 and a y-intercept, a B of 6. So that's going to be S right there. What I'm going to have you do is I'm going to have you pause this video and go ahead and answer the rest of these questions, and then unpause it when you think you've got it, and we'll check it. Okay, let's see what you've got. For my second one on here, I got that my y-intercept was negative 6 and my slope was down 1, right 1. So I'm looking for a y-intercept of negative 6. That's going to be right here. This would be y equals mx plus negative 6. And my slope is negative 1, so that one's going to be an A. All right, I've used both of those two already. This guy, my y-intercept is negative 1, so I'm looking in my y equals mx plus b's to find one that has a negative 1 at the end. I'm left with these two. And in this case, it was going downhill, down 2, right 1, so my slope is negative 2. So that's going to be H. And then we go down here. My y-intercept on this one, it hits the y-axis at negative 2, that dot right there. And my slope was up 1, or up 4, right 1. So the only one that matches up with a y-intercept of negative 2 and a slope of positive 4, it's going to be this A right here. My last two, this one had a slope of up 5, right 1. There's only one 5 up here. That's going to be the R, and the y-intercept was a negative 4 down here. So I'm going to use R. There was my y-intercept of negative 4. This one had a y-intercept of negative 1, and it went up 1, right 2 to get to the next point. So up 1, right 2, rise over 1 would be a half. So I need one with a slope of a half and a y-intercept of negative 1. And here we go, right over here with this A. So the answer for this one, if you read it out this way, is the Sahara, which you guys probably knew. So there's our Sahara. All right, we are going to go back and we're going to look at the only thing that makes this a little bit more difficult is what if the equation isn't in y equals mx plus b? So you guys know how to change it if it is not in y equals mx plus b. We just need to review that a little bit and then make sure we can graph it from there. So we are going to go back into the notes and look at page 29, and we're going back to the bottom of page 29 where we just did some examples with these. But let's look at number 2 here. The instructions for this says identify the slope and the y-intercept of the line with this equation. Is this in y equals mx plus b right now for us to even see that? No. So the only thing we have to remember how to do, and this is a review, is to put it into y equals mx plus b. Then we can see the m and the b. So to put it into y equals mx plus b, I'm just going to remind us that that's our goal. Y equals mx plus b, we need to get the y by itself. So as a review, to get the y by itself, we need to get rid of these x's first. So I'm going to take away 4 x's from each side, because 4x minus 4x, bye-bye. We're going to be careful because now we've got negative 2y left. And we talked about how you can't do 8 minus 4x and make that 4x. We can't combine terms because they're not like terms. So all we can do is write out 8 minus 4x. But we know we're going to make it plus b eventually, so I'm just going to change this to plus a negative 4x. Just rewrite that because I know I want that plus in there at some point. And now just to get the y by itself, I need to get rid of negative 2 times y. So to get rid of negative 2 times, I divide everything by negative 2. And on this side, it means I have to divide everything by negative 2. That 8 and that negative 4x divided by negative 2. This just becomes y on the left-hand side. That was the point. And positive divided by a negative becomes a negative 4 here. There's a plus. And then be careful, this is now a negative divided by a negative becomes a positive 2, and I still have my x. Look, this one didn't even leave us with any fractions. So we're going to put this in a different order so that it is exactly in y equals mx plus b by using the commutative property and just flipping around the terms. 2x plus negative 4. So there is our y equals mx plus b. If it is in this format, can we graph this now? Now do we know the slope? Which one's the slope? The 2. The 2 is the slope. Which one is the y-intercept? That -4. Y equals mx plus b. So the most we'll have to do is, if it is in this format, which we call standard form, we need to be able to put it in y equals mx plus b so that we can start with so that we can see the slope and the y-intercept. Now, if we were to graph this, just a quick reminder, I'm going to make my own quick graph here. What would I begin with? I want to begin with the b, the y-intercept, and I'd go down to -4 and put my dot there because I know this line hits the y-axis at -4. And then from there, I could count the slope. And I'm going to make that slope a fraction, 2 over 1, because the slope is the rise over the run. So I'd go up to right 1 and put a dot, up to right 1 and put a dot, and I'd have that line graphed. Ooh, if I could connect my dots there. So this is the part that takes a little bit of time to get it into y equals mx plus b, but then we can graph it really quickly. All right, so we are going to look at how to do this quite a few more times. Let's take a peek at, let's go forward now to, how about page 32? So page 32 has practice graphing all sorts of equations and just putting them into y equals mx plus b also. So this one has a joke. What's it called when a giraffe swallows a toy jet? We'll find out. The top half here, the first 9 problems, are just more practice putting into y equals mx plus b. So we'll do those. Once we do those, these last 6 are practice putting into y equals mx plus b and then graphing it. So I'm actually going to start, and I'm going to do number 10 with you, because that has you do both things. Put it into y equals mx plus b and graph it from there. All right, so let's do number 10. And this one actually has a work page for you right next to it, which is nice. You don't have to flip. So I'm going to go to the top of my work page. I'm going to write number 10. This is 2x plus y equals 1. All right, our goal is we want to be able to graph this using slope-intercept form. So we want to put this into y equals mx plus b. Can we do that? How do we get rid of the 2x that's in our way of having the y by itself? Subtract 2x from both sides. 2x minus 2x goes bye-bye. We get the y equals, now this one we're lucky because the y is already by itself. So y equals, and then we'd have 1 minus 2x. We can't combine those. They're not like terms, so I just rewrite it out again, 1 minus 2x. And I know I'm going to need to make that y equals mx plus b, so this is going to be a plus a negative. Now, guys, if this had a coefficient in front of this, if this were like 4y, we'd have to divide everything by 4. We're lucky in this case that it's not. The y is already by itself. So this is almost in y equals mx plus b. The only thing we have to do is switch around the order to get that term with the x first. So y equals negative 2x plus 1. So there is our equation, y equals negative 2x plus 1. I am going to just rewrite that over on our other page. Y equals negative 2x plus 1. Okay, oops, there we go. This is the exact same equation here. It's just manipulated. It's moved around so that the y is by itself. So this is really what we want to look at. Once we see this guy, we can graph this by using our m and our b. So what is our slope? Our m is negative 2. It's the number in front of the x, the coefficient. And the b, the y-intercept, is 1. So what's our process of graphing this now? We begin with the b. The b stands for the y-intercept. So that's where this line hits the y-axis. So where does it hit the y-axis? At 1, when y is 1. That's our b. We begin with the b. And then from there, we use our information about our slope. We know this slope is negative 2. So which direction is this line going to go? It's going to go downhill, something around here. It's pretty steep. So can we count rise over run just from this number 2? I'd need to make it negative 2 over 1. So my rise is going to be negative 2, and I'm running to the right 1. Since I'm going downhill, that really means down to right 1. If it were positive, it would be up 2, right 1. Negative is down 2, right 1, and I'm putting a dot. And when I count down 2, I'm counting from the point I know, from the y-intercept, to get to another point on this line. Down 2, right 1, I can continue that pattern. Down 2, right 1, and it's going to be on the line. I could go again, down 2, right 1. What if I wanted to continue the pattern this way with my dots? Instead of down and right, I would do the opposite. I would go up and left, up 2, left 1. And there's my full line here. So we can see as we connect the dots that this one is going to be going through this letter N. So that's going to help us with our riddle. So let's see, that was number 10 going through the letter N. I'm putting that in at the bottom. So your job is to go through and turn all of these first 9 and all of the rest of these down here into y equals mx plus b. And then you'll come and finish the graphs to practice graphing these from y equals mx plus b at that point. And then you will be a master at graphing any equation just by figuring out the slope and the y-intercept. All right, you guys can work on page 32.